asks us whether the sum of two rational numbers is always going to be rational. So we can first approach this problem by thinking about the simplest case in which we are adding two integers. So say we wanted to add 2 plus 4. These are both rational numbers. They have no decimal places, just plain integers, and our answer will be 6, which is also a rational number with no decimal places. This problem can be a little bit more complicated when you look at it in terms of numbers with repeating decimals. So say, for instance, we wanted to add 10 ninths to 157 over 495. And we can write out these two numbers in terms of their decimal versions. So 10 ninths is equal to 1.111, repeating forever. And 157 over 495 is equal to 0.317, repeating. So we can see that both of these numbers are rational numbers because they have the repeating decimal places. And we can decide whether this answer is going to be rational by writing out a few terms after the decimal place and adding them together. So we'll write 6 terms so that we can see 2 full rotations of our 0.317 repeating. So 1.111111 plus 0.317317. We'll add starting from our right side. So 1 plus 7 is 8, 1 plus 1 is 2, 4, 8, 2, 4, and then our 1 in our decimal place. So we can see that our answer is 1.428 repeating, which is also a rational number. So the answer to part A is going to be yes, because we know that we have a set number of repeating decimal places, and when we add them together, they are always going to be another set of repeating decimal places. And I will add another page here. So part B asks us whether the sum of two irrational numbers will always be irrational. So this problem, you might say yes immediately, because say we had pi plus pi. Our answer is going to be 2 pi, which is still going to be an irrational number. But when we want to find the sum of two numbers, we can think of it as the sum of a positive number and an irrational and a negative number. So say we had pi as our first irrational number and negative pi as our second irrational number. These are two irrational numbers, and we're adding them together, so it's still the sum. But our answer is going to be 0, so they will cancel out. So we can say, no, the sum of two irrational numbers will not always be irrational. It will sometimes be irrational, but the statement always is what makes part B false.